Okay, so for the recap, for the recap of the last class, we understood the forget gate, that it builds that what need to be forget according to this sigmoid neural network. Now the next is input gate, and this is here, this part is your forget gate. This is forget gate, and when you are seeing this part, this is here your input gate. Okay, and this third section here, this part is your output gate. Okay, so what is this input gate made of? So if we want to add some new info, if we one second. Okay, so if we want to add new info to the cell state, cell state is which one? This one, this upper line which you are saying ct minus 1 or ct. Okay, based on the current input or the previous hidden state, based on current input. So based on current input xt and previous hidden state. So can anyone tell me what is previous hidden state? It is ht minus 1. So that is the, so based on this previous hidden state and the current input, what we need to add in the cell state, that is what the here our input gate. This is not forget gate, this is input gate. Okay, so now let's see some mathematically. So actually this input gate works on 3 stages. It works in 3 stages. And now what is first stage? To calculate CT, this hyphen. And what is this CT hyphen? It is actually a candidate cell state. Candidate cell state. So if you would see it here, just talk to this 10H neural network. This is your candidate cell state. See, and there is a hyphen here. Candidate cell state. Okay. So first we need to calculate the, and sorry, I had just missed this line. There is an here network connection here, and I think here also. This one also, just give me a minute, let me verify the image. I think it is there, this image. Yes, this is, here it is. Here, okay. Now, so what we need to do, we need to calculate the candidate C, this one, okay. And so how to calculate the candidate C state? So this is the first thing we need to do. So how it will, based on the current input. So this CT will get calculated in based on the current input here and the previous hidden state. because see this value which is coming here, this is going here, this is the combination of your current input and the previous hidden state, that it is going it here, right? And we try to find it out the candidate value to add in the cell state. So here we will, this one we will find, right? This is the information which need to be added here. You can see here the plus sign is there. This is matrix addition. If you can see, this is the plus sign. So this is matrix addition. Now this is clear, right? Candidate cell, candidate cell state, it needs to be calculated based on the current input and the previous hidden state, and these things will get added in the cell state. Now we need to calculate IT. So IT is this one, this input gate at time t value, this one. So this is also the combination of the current input with the previous hidden state, but here the neural network is sigmoid. So it decide which part of CT is required. Now just understand, this is just a filter over this network, because see whatever it will come here, what I said it in forget gate, what is the work of sigmoid? It will make 0 or 1. If it is 0, it is not important. If it is 1, it is important. If it is made of this, it is 50% important. So if you will see the intuitive, so you can make an intuition, or you can understand it by seeing it here. Whatever the value will come from the 10H, and then some value is coming, some vector is coming it from the here neural network, and then I'm multiplying this two. So let's suppose from 10H again it came 654, okay, and then I'm multiplying it with 0 0.5, 0 0.5 and 0 0.5. So it will become 3, 2.5 and 2. This vector will become. So in both the cases it is decreasing, but why I'm saying this is the addition? Because if you see it here, this is here, I'm trying to add the matrix with the previous cell state CT minus 1, and whatever the CT minus 1 will come, in that I will add. Whatever the vector of CT minus 1 will come, in that I will add. That is how. So we can see this IT, this input gate, is a filter over the candidate cell state. Understand my point? Or is there any confusion in this that you will not able to understand? This one, this is IT. See this. This is IT, this is CT. So here the IT, if suppose the IT came with this value 0 0.5, 0 0.5, 0 0.5. This is the IT vector, and 10H here, this CT, this part. And this CT came 4, 5 and 6. And you can see here, this is a matrix multiplication. If you remember yesterday, I told if this sign is matrix multiplication. So if you multiply this IT and CT, this all value will become half, 2, 2.5 and 3. And this one you can see here, this is a plus sign. So yesterday I said when there is a plus sign, so whatever the value is coming from here, in that I will add. So in that I will add CT minus 1. So now what will be the equation for this? So equation for this is, see, the function is tan h. The function is tan h. Okay. In that we have our weight matrix. So weight matrix of what it is, this input gate. Okay. So we can write it whatever. So WI am writing weight matrix of input gate. Okay. Now here is the concatenation of HT minus 1 and XT. This is the concatenation. If you see it here, this is XT and HT minus 1. It is coming in that in tan H. Okay. And then after the bias. So, oh sorry. So this is the bias of the candidate. No, so okay, let me write here it C. So weight of the candidate cell and weight of the and bias of the this. So again, this one, what will be the dimension of this matrix? Can anyone tell me? What would be the dimension of this WC? If you remember, I said if nodes are three, and for the if nodes is equal to three, and if suppose for the word the vector are of dimension four, so it will be like this. Your xt will have the four inputs and your ht minus one, because this t minus one dimension depends on the nodes which you have selected. So here three. And now as 3, so in tan h there will be, here all these will be tan h, tan h, tan h, tan h, and this all will be connected. Okay, so this will be again, here you will get 7 cross 3. So this matrix will be 7 cross 3, and ht minus 1 and xt, this will be 7 cross 1, and this is again here 3 cross 1, because 1 bias to each, 3 cross 1, and this is why, because this all are 7 cross 1. That's why I'm saying. So now if you have to, sorry, 3 cross, this is 3 cross 7, not 7 cross 3, sorry, 3 cross 7, this here also 3 cross 7. So you will do multiplication with this, here you will get 3 cross 1, and this one if you'll do here, this is 3 cross 1, and so this one will actually go to that with transpose. So here 3 cross 1, 7 7 3 cross 1, and this is 3 cross 1, so this will be the transpose of that, it will go, so 1 cross 3, so 3 cross 1 and 1 cross 3, so it will become here, or it will be 1 cross 3, 3 cross 7 and 7 cross 1, so this is 3 cross 1 and 3 cross 1, so this is 1 cross 3, so 3 by 3 it will. So this is how, but it should not go 3 by 3, 3 cross 1, this one if I'll make 1 cross 3, so 1 by 3, there is 1 second. Here sorry, I was doing mistake, I was doing multiplication here. So this is the multiplication, this is the addition. So 3 cross 1 to 3 cross 1, not transpose, is normal. So if we'll just add 3 cross 1 to 3 cross 1, so it will 3 cross 1 final matrix will come. So in a tan h 3 cross 1 matrix will come. So this is how your tan h means this part will get calculated, this part. Okay, now when tan h got calculated, the same way your it is your input get, this one will get calculated with the sigmoid, and in the sigmoid wi is the weight of the input gate, and then it's a combination of ht minus 1 and xt, and plus it will be bias of the input gate. That's it. Again, this one will be 4 to 3, so 3 cross 7, this is 7 cross 1, and this is 3 cross 1. So if you multiply this, it will become 3 cross 1, and plus if you do this 3 cross 1, you will finally get 3 cross 1 matrix. And this 2 you have to multiply, because this is your candidate cell in CT. So CT and IT should get multiply. You can see it here. This is CT and IT should multiply, and whatever the value will come, that will get added to the CT minus 1. Correct? So this is how we will able to calculate the input gate as well. Is it clear? Now the last gate. Sorry, 3 into 1. Yes, IT is also 3 cross 1, CT is also 3 cross 1. So see, this is 3 cross 1 and this is 3 cross 1. Okay, so for multiplication it need to be get transposed. So 3 cross 1 into 1 cross 3. Okay, so this one will get multiply here. This one will get 3 cross 3, and whatever this 3 cross 3 will come, this 3 cross 3, this one will get added with the CT minus 1, because see, and the CT minus 1 has the same dimension. If we have done it, node has taken 3, so it will be 3 cross 1. So in that we will add this. That's it. So this is what here the addition will happen with the CT minus 1. In CT dash, IT dash, this both get multiplied and then it got added with the CT minus. No, this is not IT dash. This is CT dash. Why this is CT dash? Because we have already CT. That's why we have making here is hyphen. Now we have, sorry, OT here. I'm coming on that. Now the next and the last is output gate. Hmm. Now, so what is output gate now? So output gate, it is utilizing what we need to show in final output, or you can say in CT and HT. So that is how here this CT and HT. For that, what we need to do? So it is again simple. If you would see it here, the combination of HT minus 1 and XT will come here. It will go to the sigmoid network, neural network. Then whatever you have done the addition here, this one, this addition part, this one get passed into the 10H. You can see this is from here, this is here passing it from the 10H. So this is now your CT. This is one of the CT here. Your 3 cos 3 plus 3 plus 1 when you are adding, this is the CT. One output will come. And other, this value will pass to the here. If you see this area, it is passing through the 10H. This 10H. This part. And whatever the combination of HT minus 1 and XT is going through the sigmoid neural network, and whatever the output will come, and whatever this output, this one will get multiplied, and that will be your final HD. That's it, nothing else. So how it will look like, see this 10H CT minus 1. See this, whatever the CT minus 1 is coming, that will be fed into the 10H here. This CT minus 1 is coming, no, and this one is getting fed into the 10H. So you can see this is, and what is currently CT minus 1, this is, which we have just calculated into the input gate. Into, we have to multiply this OT, because see, this is the multiplication, and with what, OT. And what is OT? OT is the sigmoid of the, what is OT? OT is the sigmoid of the your some weight output multiply by combination of HT minus 1 comma XT plus bias of this. This is the OT, and this will get multiplied, and you will get your final output for that HT. So this is how HT and CT will get calculated. So this is the entire working of the LSTM. Okay. Yes. Okay. Okay. So if you'll see this sigmoid, it lies from this, the value lies from 0 to 1. This is the minimum value, this is the maximum value. But in tan h, it goes from -1 to 1. This is the minimum and the maximum value. Okay. So if you will see it here, so see, they have used this tan h and they got the result, and here tan h and they got. But if you will use the framework and the LSTM API, this entire activation. But if you want, you can customize this 10H. In spite of this 10H, if you want to use the ReLU, if you want to use leaky ReLU, if you want to use CELU, you can use that. And you can see the how the performance is coming. Okay. But they have done the hit and trial, and based on that, they have come up with that activations that this neural network with the 10H and the sigmoid was working fine for the LSTM. Okay. See, if anywhere, if you want to remove something, you will use, they are using sigmoid. And if they want to add something, they are using this. Notice, see that here. Here they have used sigmoid to remove it. Here, whatever the things are coming from the 10H, because this input get is to add. But in addition, also they were filtering something by using this sigmoid. And again, they were not taking the entire previous hidden state and the current input, they are filtering some data from that, and from the 10H whatever it is coming, no, again they are filtering from the 10H. So if you notice that all three gates, they were filtering it by using the sigmoid, but whenever they want to add the information, they are using 10H. Yes. So this is our yes. On Saturday we will see how embedding works, and the first is we will see TF-IDF. Apart from the TF-IDF, there are also very basics, but we will not go to that. And word to wake. And in word to wake, one is pre-trained model and one is custom trained model. How this model got trained, and we will train our by using our own neural network. Okay, so this is the agenda, and once we will understand this embedding, no, we will go with one project, and then we will move for the transformers. Okay.